Alright, so on this homework problem, you were first to try it on your own and then watch this video to see if you got it right. Um, so this is really the toughest problem that I can ask you really with using the definition of the derivative. Alright, so the idea is you start here with a limit as h goes to 0, and you want to do what it says. And so it says f of x plus h. What that means is wherever you see an x, you replace it with x plus h. So this is really 2 divided by x plus h. Right, so that's f of x plus h. And then minus f of x, which is just 2 over x, all divided by h. The next step is to get a common denominator, so you can bring these two fractions together. So this is a limit as h goes to 0. It's really simple to get a common denominator. All you have to do is say, okay, what doesn't this have? All right, it has an x plus h, but it doesn't have an x, so you multiply it by x. And if you multiply this by x, you better put an x up here so you don't change the fraction. And over here you put in x plus h. And again, you have to put an x plus h up here so you don't change that fraction. And so what we have in the end is that this is the limit as h goes to 0 of 2x over x times x plus h minus a 2 times x plus h, all divided by x times an x plus h. And of course this is still all divided by h. And once you have a common denominator, you can bring the numerators together. So it's the limit as h goes to 0 of 2x minus a 2 times x plus h, all divided by x times x plus h. And of course that's all still divided by h, which is equal to the limit as h goes to 0 of, and so what we have here on top, we have 2x, and we distribute this negative 2 through, so minus 2x, and then negative 2 times a positive h is a minus 2h, and the bottom here we still have x times an x plus h, all divided by h. And so this is equal to, what we're going to get is some cancellation over here. If you have 2x and you take away 2x's, they're going to cancel. And so this is going to be equal to the limit as h goes to 0 of a negative 2h, all divided by x times x plus h. And this is all divided by h, right, which is equal to, and so now when I divide by a fraction, right, like h over 1, right, divide by h is like dividing by h over 1, I multiply by the reciprocal, so I get the limit as h goes to 0 of minus 2h, all divided by x times x plus h. And then times the reciprocal of h over 1 is 1 over h. And again, what we're going to get here is that h's are going to cancel. So h's cancel, and then this is equal to the limit as h goes to 0 of minus 2 over x plus h. Right. When these h's cancel, we lose this indeterminate form. Right? If you plugged in 0 here, you get 0 on top and 0 on the bottom. But now that they canceled, we can now plug in 0, so minus 2 over, notice h is 0, x is left alone, so x plus 0, which is equal to a negative 2 divided by x times x, which is an x squared. And so the derivative of f is negative 2 over x squared.